This is UMOZO3. In the previous lesson, we learned about another type of queue. We talked about a concurrent linked queue, which we said basically has the same functionality as a queue. Okay, it's a first in, first out data structure, but it's just another available data structure that you have available to you. Okay, and we said that there's basically now we're aware of two different ways to create a queue. Okay, basically what we could do is we could either import a queue and a linked list and declare an object as belonging to the queue interface, but initializing it as a linked list, right? We talked about that in lesson 53. Or we can go ahead and import java.util.concurrent linked queue. So you need this .concurrent here, but this enables us to create a concurrent linked queue. And that's what we're going to be reviewing in this video. So what we said is that we have to go ahead and import that class. You want to make sure that that's at the top of your Java file, but before your class is defined. And then you would say concurrent linked queue of type string. Any data type can go into your queue, and then name it. So we would just say my queue equals new concurrent linked queue of type string. So that would declare and initialize a new concurrent linked queue. And we can go ahead and remind ourselves of what the documentation is for this particular data structure, right? So you would just go to blackle.com and type this in, and it just says that it's a queue that orders elements first in and first out. So it sounds a lot like the more general queue, okay? And you can see a lot of hyperlinks on this API. So if you get curious about something, like we're studying concurrent linked queue, but you already know what a queue is, right? And it says that a queue is related to this. So then if you click on the queue interface, or we've already studied this documentation before, we know that we can add elements to the back of a traditional queue, like an original queue, a regular queue, but now we're talking about a concurrent linked queue. So it's another type of queue, and you don't initialize it as a linked list, you actually just initialize it as a concurrent linked queue. So it is created a little bit differently from a regular queue. It's declared and initialized as a concurrent linked queue. Whereas when we were doing queues originally, like previously, we initialized it as a linked list. So hopefully that's clear to you. But we would import the class and create a concurrent linked queue, and we would say concurrent linked queue of type string, my queue equals new concurrent linked queue of type string. And you could say my queue.add of tennis, and then you could say boolean b equals my queue.add of hockey, because if you look at the documentation for the add method, it's instructed to return a boolean, and the boolean is always true. That's what we talked about in the previous video. And so you would just say boolean b equals my queue.add of hockey. And so this does two things, right? So this assigns b to true and adds hockey to the queue, to the concurrent linked queue. And then you could say boolean c equals not my queue.add of tennis. So now tennis would come into the back of the queue, but c would be assigned to false. And then we say my queue.add of basketball, my queue.add of cup. And then you could say system.out.println of b and c, and we would get false for that, right? Because if we have a true and false, then that evaluates to false, like we talked about at the beginning of the curriculum. And then if we say system.out.println of my queue.peak, that would basically give us the front of the concurrent linked queue without removing it. And so we could have a new peak. Let's have a new peak. So I'm just going to add something. This guy's going to skip in line and just come to the beginning of the queue. And I'm just going to say tail. Okay. Actually, let's call it something else. Let's call it mouse. Okay. Because I don't want to confuse you. So what we're going to do is we're going to compile it, and then we're going to go ahead and run it. And we can think about the output that we got here, right? Because we said false because b and c evaluates to false. And then if we call my queue.peak, right, just like with an original queue, just like with the queue interface, we have an add method and a peak method and a poll method and an isEmpty method. Those methods, those same methods also show up in the concurrent linked queue class. So this is just another alternative. It's just another option that you have available to you as far as creating a queue goes, right? And then you can go ahead and compare the input and output here. So I guess the code, so we would just go ahead and print false, and then we would print mouse, right? So I guess mouse would be the new head of the queue. That's what we would peak on. And then we could go ahead and iterate through the concurrent linked queue. So in pretty recent videos, we've been talking about different types of iterators. And one of the things we said is that a concurrent linked queue, or queues in general, only have one iterator available to them, and that's just the regular iterator, right? We also talked about an enumeration. An enumeration is like an iterator, but it has longer method names and doesn't provide a remove method. So there's really not a whole lot of reason for using an enumeration when you could use an iterator, okay? But you can't do a list iterator, okay? So you can't traverse a queue backwards. You couldn't look at the back of the people in the supermarket and then traverse your way to the front. You couldn't do that, but you could say, while w.hasNext, after creating an iterator of type string called w on my queue, system.out.println of w.next.toUppercase. And so that's why we print those 6 elements that were added to the queue one at a time, starting at the beginning of the queue and working our way to the end. And then if we say system.out.println of my queue.isEmpty, that would go ahead and return true, because after we call remove over and over again, the queue would be empty. What if we go ahead and comment out this call to the remove method? Well, then presumably our queue is not going to be empty at the end of the main method. So that's why we get false there instead. So hopefully that's clear to you. And so we've just been trying to understand what different iterators are available to us for different data structures, right? So we've been talking a lot about this, right? So for a particular array list or linked list, right, you can call list.iterator, right? Or you could also call list.listIterator, okay? And so this is basically, this is a class that provides even more functionality for manipulating the inherent data structure, the underlying data structure, right? But if you look at a concurrent linked queue, there's only one type of iterator available to it. And we just saw an example of that. But we can go ahead and think about these other data structures. We're trying to compare and contrast data structures and think about the different types of iterators that they have available to them. So for example, with the linked list, we said that linked list gets 2 of them. So it gets an iterator. So that would actually come from abstract sequential list. Okay, so if you think about the class hierarchy, it turns out that linked list is actually a subclass of another class called abstract sequential list. An abstract sequential list has a method called iterator on it, which is why the subclass linked list is allowed to use iterator. But you don't see you don't see elements here. You see element, but you don't see elements. There's no enumeration. And there is a list iterator, right? So we say list iterator. So we get an iterator and a list iterator for an array list or a linked list, right? And then we said for a vector, we get an iterator, an enumeration, and a list iterator. Okay, so hopefully that's clear to you. And then with a set or a queue, we only get an iterator. Okay, what about for a stack? So for a stack, we can go ahead and think about the documentation for that. But one of the things you might remember from the previous video is that stack is actually a subclass of vector. So if we can go ahead and look at that. This all shows up, all these class hierarchies will show up in the Java API, and you can go ahead and understand how these different classes are sort of arranged in a hierarchy, right? You have to remember that object is the superclass of basically every class, but stack extends vector. So a vector provides an elements method, an iterator method, and a list iterator method. Then presumably all 3 of those iterators are going to be available to a stack as well, right? If you look at the method summary for stack, you don't see iterator, list iterator elements because they don't appear for the first time in stack. They appear for the first time in a superclass, presumably vector or abstract list, right? But you can see that there's a lot of methods that are inherited from vector. What are 3 of them? Elements, iterator, list iterator. Let's click on elements. You just click on the hyperlink, and it tells you that it returns an enumeration on the components of the vector. And we're saying that a stack is technically a type of vector. You can access elements of a vector by index position. You could technically do that with a stack. You could figure out the element at index position 2 of a stack, but typically we reserve array lists and vectors for really when we're talking about index positions. We usually just want to think of a stack as being more of just a last in, first out compilation, okay? But those methods are available to you, and the point is that for stack you get all 3 of them. So you get an iterator, an enumeration, and a list iterator, okay? And so we can probably go ahead and review list iterators a little bit more in this video as well, okay? And then we can also talk about a hash map. Okay, so what about maps? So we said that we could return an iterator on the key set or on the values, right? Or an enumeration on the hash map itself, and that would enumerate on the values, right? And so we can go ahead and remind ourselves of that documentation, right? But you would go to, actually, I think only, we have to see what methods are available here. So with hash map, basically, what we would have to realize is that you can actually, with a hash map, you can return key set, okay? And that would return the set of keys. And then on that set, you could iterate through the keys, right? So you could call it iterator on the key set. So we could maybe see an example of that in this video, right? But, and then, so then hopefully that's clear to you. And then also with, so these are the two types of dictionaries, right? We talked about another type of dictionary called a hash table, but hopefully you're able to compare and distinguish and contrast these different data structures. And then the one that we talked about most recently is called a concurrent linked queue, and it only has an iterator, just like the queue interface as we studied previously. What we're going to do in this video is talk about another type of set. So we've already talked about sets. We know that sets is a data structure where there can only be unique elements, right? There are no duplicates permitted into a set. And so what we're going to do is we're going to study the documentation. We can go ahead and remind ourselves of what the documentation is for the HashSet class. Remember HashSet. So HashSet is how we implement a data structure where only unique elements are permitted into it. And so we've already studied that a set can only have unique elements, right? And so there's probably a little bit more information than you might be interested in here. But these are some methods that we have available to sets. We can add elements, we can remove elements, we can get the number of unique elements in the set. We can see if the set is empty, we can return an iterator on the set, okay? And we can clear the set. But those are basically the things you can do with sets. And so HashSet is actually, it turns out that it's actually going to be a superclass of another type of set. So we're going to learn about another type of set called a linked hash set, okay? And so you can go ahead and either click on the hyperlink from the HashSet API, or if you're not here already, you just go to blackle.com and you type in linked HashSet Java, okay? But you would go ahead and click on it, and you can learn about this linked hash set, and it's actually a subclass of HashSet. So just like in our discussion of inheritance, every time a superclass has a method, that method is going to trickle its way down to the subclass, and the subclass might override it, but not necessarily. Maybe it'll just be the exact same implementation as the method was defined in the superclass. But this is a linked hash set, and it says it's a linked list implementation of the set interface, okay? But it basically differs from a hash set in that it maintains a doubly linked list running through all of its entries, okay? And so that's probably a little bit more detail than you really need to be worried about for the purpose of this video. But the point is that it just gives you another way to work with a set. It's just another option that you have available to you, right? We already said vector is an alternative to an array list. A hash table is an alternative to a hash map. A concurrent linked queue is an alternative to a queue. And now a linked hash set is an alternative to a hash set. It's just a subclass, but it's up to you. You can either use the superclass one or you can use the subclass one. And if you look in the documentation for the linked hash set, we can go ahead and scroll down. There's 4 constructors. There's 4 ways to create a linked hash set. And we're just going to be focused with this default constructor, so the one that doesn't accept any arguments. There's only one method that belongs to the linked hash set class that does not belong to the hash set superclass. And that's called splitterator, okay? And we're probably going to skip that for this video. But the point is that it's a very, very similar subclass, okay? It doesn't really do all that much more than HashSet does. They're very, very similar, okay? And so we can just go ahead and compare and contrast them. And so in this video, not only do we sort of get to talk about linked hash sets for the first time, but we get to review hash sets. But we're going to say import java.util.linked hash set. So, you know, just every single time we are going to want to use one of these important data structures, you have to go ahead and import that particular data structure that you want to use. And then if you want to use a particular iterator on it, with hash sets, we only have one of these iterators available to us, right? It doesn't really matter whether we import enumeration or list iterator if we're working with a hash set. We only really need the iterator. But what we're going to do is we're going to say linked hash set, and you have to have a particular data type. Let's do it with integers, okay? And then we're going to say my set equals new linked hash set of type integer. And so it's just like we studied with sets previously, but now we just have this extra word linked, okay? But we can go ahead and add elements, and we can think about, there's not a lot of methods in linked hash set in particular, but it inherits a lot of methods from hash set, like add and remove and is empty and iterator and contains and clear and size. And we've already studied 7 out of the 8 of them. We didn't study the clone method, but that's okay. But we can go ahead and iterate and add. Okay, what does the add method do? Well, you could go ahead and look in the superclass, because the add method from linked hash set just takes whatever add method was in hash set. And so it would go ahead and return true if the set did not already contain the specified element. So what we're going to do is we're going to say Boolean Q equals my set.add of 100. So this assigns Q to true and adds 100 to the set. And then what if we say Boolean R equals my set.add of 100? Okay, and then so what if we say system.out.println of Q or R, and then system.out.println of Q and R, and then system.out.println of my set.size. So hopefully you can predict what the output is going to be here. But since Q is assigned to true and F would be assigned to false, because 100 already exists in the linked hash set. Okay, and that's exactly how the regular hash set would work as well. But this would be true because Q is true. This would be false because R is false. And then this would be 1 because there is only one unique element. Okay, so 100, it doesn't really get added to the set twice. It sort of gets rejected. Okay, there's no runtime exception. The program still runs, but there's only one element added to the linked hash set. And so we can go ahead and think about the other methods that we have available, right? If a method is available to a superclass, it's also available to the subclass. So you sort of have to go back to the hash set documentation to understand what operations you have available to a linked hash set. But these are the operations basically. So you would say add and clear. You can clear and you can see if it's empty. So what if you say my set.remove of 100, and then what if you say system.out.println of my set.is empty? Okay, so after removing the only element that existed in the set, presumably the set would be empty, and so we can go ahead and run it. And so it says true, false, 1, true, right? And so hopefully you can understand why we're getting that output. And there's other things that you can do with sets, but there's really not that much extra content to add on to this video. The point is that there's actually a subclass of HashSet called linked HashSet, and it works in a very similar way. That they'll provide you with a couple of details about what the trade-offs are, you know, at the low level, you know, which one's faster, which one's better, which one's synchronized. But that's kind of beyond the scope of this programming curriculum. You just have to understand that linked HashSet works almost the way as HashSet does. So you can see if it contains an element and you can remove an element. We can do it real quick. We can do an iterator. Okay, so after we made the set empty, let's say my set.add of 45, my set.add of 57, my set.add of 52, my set.add of -1, and my set.add of 3. And then what we're going to do is we could basically create an iterator. So we can say iterator of type integer k equals my set.iterator. Okay, so just like a regular set has an iterator available to it, and when I say regular set, I mean hash set. But just like a hash set has an iterator, the subclass also gets it too. And so then what you would do is you would say while k.hasNext or false, right? That wouldn't really affect anything. And then you could say basically, what if we just only want to remove one element from the list? So you could say something like system.out.println of k.next. Let's just try to remove one element from the set. So we could say if u equals 0, you could say you would say k.remove. Okay, so you would just remove only one element from the set, and then you're just going to say u plus equals 1. And so this would be the implementation of how you would iterate through the elements in the set and remove one of them at the end. Okay, and so then you would say system.out.println, you could say size of linked hash set, and so presumably we would be expecting my set.size to just be 4, right? Because we cleared the set, we added one unique element, and then we removed it, and then we added 5 unique elements, we removed one of them, so the size of the linked hash set should be 4 when all is said and done. So we go ahead and run it, and it just says size of the linked hash set is 4, and we can compare the code that we wrote with the output that we got. And so hopefully that's clear to you how that works. And so those are just some of the methods that you have available to us, right? We could also say my set.clear, okay? And so then what we could say is system.out.println of my set.isEmpty, okay? And so this is just another method that you have available to you when you work with a linked hash set, as you can see if it's empty, just like we could do with hash sets, right? And then we can go ahead and run the main method, and then indeed the linked hash set would be empty after we called the clear method on it. So hopefully you're familiar going to this Java API. You just literally go to blackhole.com and you type in linked hash set, and there's going to be a lot of references to the HashSet superclass, because linked hash set sort of mooches off a hash set. Just basically takes everything from the superclass and doesn't really do too much unique things of its own, but it's just another data structure that you have available to you. So hopefully that was interesting. From UMills03, thanks for watching, and please subscribe.